Hey everyone, welcome back. In this video, we'll be taking up some examples and we'll analyze the time complexity of the same. Let me write down those examples here. Now let us try to analyze the time complexity of these two for loops. We know the time complexity of this incrementing is nothing but order of n, which is n times. Even the decrementing for loop takes the same time as incrementing for loop. Why? Because if we count the values from 0 to 5 and 5 to 0, the number of counts will be same, right? It goes that way. Irrespective of incrementing or decrementing, the time complexity of for loop will be order of n time. F of n equals order of n, f of n equals order of n. Let's take one more for loop. And we'll have some statements inside for loop. If you observe, the initialization and condition check parts are same. I will consider this as 0 itself. Yep. But the only difference is incrementing or updating statement, whereas this is updating 2 times for every iteration, which results in these statements get executing half of n times. Therefore, the time complexity of above for loop is n by 2, but after taking the degree, it becomes order of n. Even if for loop executes half of n times, but the order of it will be n, right? So the time complexity will be order of n. Even if for loop gets incremented by 20 times, which results in f of n as n by 20, but the degree of polynomial is 1, which keeps the same time complexity as n by 2, which is order of n. I hope these three examples are clear. Let us move on to our next example. In this example, only the difference is the inner loop gets executed for I times. Let me dry run this. In that way, you can understand it very easily. I'll take I, j, and the number of times inner statements gets executed. In this case, we'll consider n as 5. I loop starts from 0. I starts from 0 and j loop will not execute because 0 less than 0, which is not true. 0 times number of times statements gets executed is 0. Now I get incremented to 1 and this j loop gets executed one time because j is starting from 0, I is 1 now. It checks 0 less than 1. Yes, the inner statements gets executed. Now j gets incremented to 1. The condition is checked. 1 less than 1? No, so the loop breaks. J loop gets executed only one time and the inner statements executes one time. I gets incremented to 2 now and j loop again 0 to 2, but for the third iteration j will be 2, I is now 2. Is 2 less than 2? No. So the for loop breaks. J loop gets executed 2 times and the number of statements inside J loop will also execute 2 times. Now 3, this execute 3 times, 3 times, I gets incremented to 4, J loop executes 4 times, inner statements execute 4 times again, I gets incremented to 5. In this case, the first for loop condition is checked whether 5 is less than 5, which is not true. The for loop breaks here. In this example, we have considered n as 5, but what if this n is unknown? How many times the outer for loop and inner for loop and the statement inside both the for loop gets executed? As we know, the outer for loop gets executed n plus 1 time and j loop gets executed n time and the statements inside outer and inner for loop gets executed n times. Can't we just write these number of times as below? 1 plus 2 plus 3 plus 4 plus up to n. Can you remember some formula out of this? 1 plus 2 plus 3 plus up to n equals to n into n plus 1 by 2, which is nothing but a mathematical formula to add sum of n natural numbers. And this can be written as n square plus n by 2. To get the time complexity out of any polynomial, we will be considering the degree here. The highest degree is n square and we don't have any constant over here. So we'll consider n square as the time complexity. Therefore, time complexity of above for loop is nothing but order of n square. I hope all these 4 examples are now clear. In the next upcoming video, we'll be considering some more examples and we'll try to analyze the time complexity for the same. Thank you all for watching. See you in the next one.